Okay, morning everyone. Today we're going to be talking about the fundamentals of home cinema projection. An important subject for me. We've been involved in projection for all of this many years now. Um, I think there's been a lot of feeling that projection might be nearing the end of its useful life in home cinema design. But I have to tell you that I don't feel that that's the case. We've seen a lot of exciting developments in projection just recently, and so felt it would be a good time to do this little class that just dips into some of the fundamental parts of the whole process. Now, what we're going to do is we're going to look at some of the stuff that is already on our Surround Store website within the learning section. And we're going to use that as we look at the sort of very basics of cinema projection. Let me share my screen here. There we go. As a reminder, if you want to zoom in, you just click the main screen and you'll see it, if the full page on your screen. So this is the learning section on the website. There's quite a lot of articles and stuff like that on there. Now, if we talk about cinema projection, there's one thing that's absolutely more important than anything else. The projector has to fill the screen. Okay? If it doesn't fill the screen, we have a very terrible problem. So let's look at how we manage to make it fill the screen. So the first thing that you want to think about when you're looking at a projection system is the lens throw ratio. Okay. So this is the one that we get asked about most of all, I have to tell you. People struggle with throw ratio. So throw ratio is there because in a projection system, one of its big advantages is that it's totally flexible, but also one of its big disadvantages is that it's totally flexible. So you can't say, oh, you need to put the projector 3 meters from the screen, because of course it all depends on the relationship between the screen size and the lens that you've got inside the projector itself. So the way that you can overcome that is you use this term, the throw ratio. Okay. And the throw ratio is pretty simple. It's the relationship between the throw distance and the image width. Okay. So let's say the image width was 3 meters and the throw ratio was 2 to 1. The throw distance would be 2 times 3 meters. It would be 6 meters. Okay. Now, what you'll find is that most of the projectors that we would be looking at have like a throw range that they operate over. And that throw range might go from, say, 1.4 to 2.7. That's a pretty typical throw range that you get on sort of higher end cinema projectors that don't have interchangeable lenses. So that's a fairly typical number that you'll see there. That means that the projector can be within 1.4 times the screen width to 2.7 times the screen width away from the screen and still work. Now, a little word of warning. There's one thing that will make you cry more than anything else in this game. Lenses are specified with a tolerance, and every single manufacturer will put somewhere in microscopically small print something like lenses are specified to plus and minus 5% of the throw range. And if you get unlucky, of course, it can be a little bit less than you expected. And you get the problem where your throw ratio is too low and it doesn't fill the screen. Never, 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 never let yourself be stuck in that trap. Try very, very hard to avoid being at the very extremes of the throw ratio, because you will always risk that it doesn't quite, by a couple of percent, meet what you were expecting. Okay. There's Julian. Come in, Julian. We've not started long. Come in. Okay. Now, the next bit of throw ratio is what happens if your throw ratio is too high? Well, then you will overscan the screen. The image won't get small enough to fit. Now, in my opinion, this is a much more, I was going to say much more desirable, much less undesirable situation than not being able to fill the screen at all. But for those who've just joined, if this is your first one of these sessions, if you click on the screen at the front, it will blow up to be a full screen for you, so that you can see everything much more easily. Now, we'll not dig into too much about the throw ratio stuff here, because it's all explained with calculations and examples and all that type of stuff on the website. Now, I want to go back to this screen here. Why do I feel that that is a more desirable situation? It's because now we have unbelievable capabilities in video processing, and even quite basic projectors have got like digital zoom functions and all of that type of stuff. Now, no one is suggesting that the ideal is to be too far away, but filling the screen is always a lot better than filling the screen. And although this is a fundamental class, you will actually find a lot of projects once you start getting into aspect ratios and things like that. Overscanning the screen is a pretty essential part of the whole process. Now, I also mentioned fairly typical throw range for a kind of normal home cinema projector. I say normal, I'm talking about Sony and JVC here. Is about 1.4 to 2.7. That's a pretty wide throw range. But what if you need to have the projector much closer to the screen, like 0.9? You know, maybe you're trying to do a really big screen in a small room, or you're trying to shoot across a room or something like that. Or maybe you're doing an outdoor projection system. Not today's subject, but in those cases, you might end up needing a really long throw. Well, that's where you kind of start to look at projectors that have got interchangeable lenses. Okay, literally, you can take the lens out of the projector and swap in a new lens, and those lenses have different throw ratios that they support. If you talk about Barco, who obviously you can get through surround, you can typically go from about 0.35 all the way up to 7 in some cases. So an unbelievably wide range of throw ratios that are supported. Okay, so does anyone have any questions about throw ratio before we move on to the next one? Will you remember to fill the screen? Okay. So the next item that we want to look at is the lens shift. Okay. So if you look at the picture on the screen, that's an on-axis projector. It's in line with the middle of the screen. Now, I assume that everyone does lots of projects where, the client is looking to be sat right next to the projector, maybe sacrifice a chair for the projector to be on axis. Pretty obvious, I think, that is not a practical solution. And of course, it's never been a practical solution. What you want to do is, in most cases, you want to be able to have the projector higher up and use lens shift to move the image down the screen. Okay. Now, people seem to have a bit of an understanding of lens shift, but we still get asked quite a lot about it. So, lens shift is different from keystone. Keystone is just when you tilt the projector, and keystone introduces optical artifacts, like the image isn't square and all that type of stuff. Lens shift is different. Because this is a fundamental class, let's keep it simple. Lens shift doesn't introduce optical artifacts. It moves the plane of the lens so that the image itself moves up and down whilst retaining its correct geometry. So it doesn't introduce optical artifacts. So it's a fairly important part, I guess, of almost every project that people are working on, unless you're doing ultra short throw projectors. We'll always have a motorized or at least adjustable lens shift that we can use. And almost always we'll be looking to do lens shift down as shown in the image. Although, of course, the opposite is also true, and you can do lens shift up. You might be surprised how often we get asked to do ultra short throw projecting from like a coffee table. Still a thing people like to do. Now, one of the things though that gets people is, how do you calculate lens shift? If you look in the manual, the lens shift will be specified as something, let's say 65% vertical lens shift. You'll see numbers like that being mentioned. So what do they mean? Well, 0% lens shift is directly on axis, as you can see here, right in line with the middle of the screen. If we would move the projector so that the projector was level with the top of the screen. Remember, if this was on axis, that the middle of the screen would now be right on the top of the visible screen there. Half of the image would be overscanning the screen. So what we have to do is move the image by 50% of its image height down to fill the screen again. So 50% is a pretty important number when you're looking at lens shift, because if you have 50% lens shift, you can put the projector level with the top of the screen. Okay. Now, you will typically find 50 to 55% being common numbers. We have some Varco projectors that have insane, like 75% lens shift. The CinemaScope models have unbelievably massive lens shift. There's all the data in here if you want to go away and look at that. Now, it's important to understand, what is the thing that constrains lens shift, okay? If you think of the lens on your projector, let me just stop sharing for a minute so I can see myself. If you think of the lens, the prime lens, the big lens on the front of the projector, okay, it has a size. And if you look when that's projecting, don't look down it, you're going to burn your eyes out. Look from an angle. you'll see a rectangle of the image, basically, as it passes through the lens. Now, the lens shift is constrained by how much it can move without getting chopped off on that prime lens. So what you'll actually find is the projector will offer, just say 55% vertical lens shift. But once you've moved it 55% down, you might not be able to move it left or right. Otherwise, it would get cut off. So the more horizontal lens shift you have, the less vertical shift that you have, because it has to fit within the bounds of the prime lens. Now, there's a rule of thumb for optics. So if you want to double the size and keep the quality, it's 8 times the cost. So clearly there is a big incentive to minimize the size of the lenses. And if you can make the beams smaller, you can minimize the size of your lenses. So if you look at projectors from different companies, you'll see the size of the imager is given. If it's a DLP cinema projector, it might be a 1.25 inch chip. If you look at a more basic DLP projector, it's a 0.68 chip, half the size, 1/8 the cost of the lenses for the same quality. So that's a really important relationship between like the lens size and the shift and the cost. Pick which ones are least offensive to you. Okay, so that's lens shift, guys. Any questions on lens shift before we move on? Nope. Tom's got the hang of the chat. That's top work. Last week it was like pulling teeth trying to get people to use it. Good. Okay. So the next part that we want to look at is the aspect ratio. So believe it or not, this is probably still the thing that people get more confused about, I would say, than anything else. Let's switch the sharing back on. So I've done whole hour classes just on aspect ratios, so I will try and fly through this topic for everybody. We live in a world now where content comes in an unbelievable range of aspect ratios. It's not just 16:9 anymore. You know, you have 2.02 on Netflix, you have DCI content at 2.39 and 1.86. You have people moving aspect ratios and all of that type of stuff. There's really no way now that you can pick a screen and say that's going to fit all the content. It just doesn't happen. Now, that obviously impacts the sort of thought process of people who make projectors. Now, before we get into like more complex stuff around content though, there's one thing that catches people out all the time still. So 16:9 is equivalent to UHD. So UHD is in a 16:9 ratio. So UHD being 3840 by 2160. That's what you get when you're watching 4K on a 16:9 TV. That's what comes through your Sky and all of the rest of the stuff. If you look at a 4K projector though, so a projector from Sony or from JVC or some of the Barco models or Christie or whoever else it is that you want to use that are true 4K projectors, well, true 4K is 4096 by 2160. And it's actually a 1.9 aspect ratio. So you've got to be very, very, very careful when you're looking at your lens throw ratios if you are specifying a 16:9 screen with a true 4K projector. Okay. And you've no idea how many times I get the call about overscan on the sides, or I can't fill the height of the screen. It still happens all the time. So please be very, very, very careful to understand even the native aspect ratio of the projector. Without being fancy, you've got to understand, am I doing 4K or am I doing UHD? There's no right or wrong answer. You've just got to not get yourself in a situation where you haven't filled the screen. That's the absolute worst case. Okay. So then we have some details in here about how to calculate the aspect ratio. Now, one thing that I do want to flag, Barco are still pretty unique because Barco offer CinemaScope and UHD versions of their projectors. And that's been something that, we've always made use of. So if any of you guys can remember using anamorphic lenses or anything like that way back, or have seen those things, that is technology of 15 years ago. Okay, forget it. I'll say it right now. I just do not understand why anyone would ever consider an anamorphic lens in this day and age. It's crazy. Okay. If you want to do a native CinemaScope system, we can easily do that with a native CinemaScope Barco projector with a 5K resolution. And there's actually a different article on the website about 5K. Now, I'm even going to say I would never use an anamorphic lens, even on a Sony or JVC, for example. Much better to put that money into video processing and use electronic scaling to give you the whole sort of aspect ratio experience, in my opinion. So that's projector aspect ratio. Any questions on that one? I spouted my controversial views there. No, we're all good on that. Right, so the last thing that we've got to look at when we're considering a projector is the brightness. Okay. Good old screen brightness. So I'm not going to go into this one, but I actually quite like this little article because there's lots of things that go into the brightness that you get back from the screen. And it's all explained in quite a lot of detail in there. But basically what you've got to consider is that the projector has an amount of light that it can output. And that will be specified as a number of lumens, ANSI lumens or ISO lumens, as we now start to see all over the place, are what we're looking for. Is there such a thing as too much brightness for a projector? I've not found the limit yet where I felt there was too much brightness potential. Of course, it's how you use that brightness that's important. And it is important to ensure that we do have enough brightness that the image has vibrancy and pop. That's what we're going to have to look for. Now, the amount of brightness that you need is going to be somewhat dependent on the viewing situation that you have. So if you're doing a black room cinema with black velvet walls and the wife will never go in the room and it's clearly the man's plaything, you can get away with a much lower image brightness because there'll be no reflections or anything like that, no source of ambient light that needs to be overcome. If you're maybe doing a media room though that's got lighter coloured walls and maybe a little lamp or something like that, you will probably need to think about a much higher level of brightness. Because remember, a projection system works by reflecting light back off a screen. The blackest black that you get on a projector screen is determined by how much ambient light there is. You can't make it darker than the lowest level of ambient light. So you need to have more than that ambient light to get any sort of detail in the image. I guess for me, typical systems that we're looking at, I wouldn't really be considering anything these days under 2000 lumens. We're always looking for that. Yes, the darkest grey, Tom says. Absolutely. I have been lucky enough that we've been involved with systems with projectors of 15,000 lumens. I think the brightest one that we've been involved with was 32,000 lumens in a home cinema. Man, that's bright. The screen was 6 meters wide, but what are you talking there? Probably 400 nits, 500 nits, something like that, calibrated. It's bright. It's impressive. No good if you're watching SDR, it'll burn your retinas out. But if you're using that for your HDR with tone mapping and all of those types of things, your sunset looks pretty realistic when you've got that level of brightness. Yep, so there you go. So I don't personally get hung up about having too much brightness because it just doesn't happen. You can always use more brightness, in my opinion. Just don't ever, ever, ever underspec the brightness. And if you're looking at like serious cinemas for people, 1500 lumens or something like that, what are you going to be putting it on a 2-meter screen? So you've really got to watch that. Now, of course, there's another part of this, which is about the luminance. What's coming back to you off the screen? We're going to talk about that just at the end of the session, okay? So I'm not going to dwell too much on that. What you see on a projector is always a system. It's the projector and the screen. Don't forget that. We'll talk about screens just at the end a little bit, though. So there we go. That's brightness. So does anyone have any questions on brightness before we move any further? Nope. Tom's added some comments. You've always got to be careful of contrast, of course, which I'm sure we'll go into. Okay, so the next thing I want to look at then, we've chosen our projector and we've made it fit. But what considerations do we need to have now around that? So let's just look at some of these options that we've got here. Well, really the biggest challenge of a projector is its cost, its physical size, and how much noise and heat it puts out. Okay. No real surprise. Anything good in life tends to be expensive, noisy, and awkward. so no real surprise to us there. And that's the reason why you'll see most companies have a range of solutions. So here we're looking at the Barco range. Okay. Now, i600 is a kind of a new model. 4K resolution, 8000 lumens. It's really designed for more media rooms than cinemas because it makes some compromises in its potential color saturation to get to that level of output. The kind of same size model is the Bragi, and the Bragi makes absolutely no compromises on contrast and color, but it is much less light output, 2000 lumens roughly on a Bragi. So two models physically the same size that have had a couple of changes done to deliver dramatically different Image parameters. A Bragi also is very quiet, a little bit quieter than an i600. So, they're fairly typical things that you'll have to play around with. And I think you would agree with me, they are fairly typical looking projectors. What about these guys, though, down at the bottom? These are the cinema at home models. So something like a Nerthus, thing is quite good. Let's face it, the Nerthus is truly an unbelievable output that it produces. How big is that model? Let's just quickly look in and we'll see how big an Nerthus is. So, he's only a little guy. 760 millimeters by 1500 millimeters, almost by 600 millimeters. 170 kilograms. 51 dB, 12,500 BTUs. Are you man enough for an Nerthus? That has to be the question. Clearly, no one is expected to take a Nerthus and hang that from the ceiling. So there has to be consideration around the projector model that you're going to choose. Because if you deal poorly with the physical challenges of that, of course it's going to deliver a very poor experience for your customer. The Nerthus is the best image I've ever seen in my entire life. It's not even close for me personally. But yeah, the thing is loud and hot and gigantic. If you put that just in a room, of course it's going to be a terrible experience. No one would ever want to do that. You're going to have to come up with a strategy to handle that. Now, let me just address the Heimdall. This is not really a sales thing, but the Heimdall is kind of the sweet spot projector for us. It's not too big. It's not too hot. It's not too noisy. It's actually very quiet, 29 dB. It has very good light output, between 4,000 and 6,000 lumens, depending on the model. It has interchangeable lenses. It's available in native CinemaScope. It's a pretty unbelievable platform that kind of does everything incredibly well. So we're pretty excited about the Heimdall. It's taken a little bit of time to get ready, but it's there now, right in the middle of the Barco range, delivering pretty much everything that you could want. So we're obviously very, very excited about that. Let's come in here. Hi. Come in, Jeremy, come in. Now, what do we need to consider with these projectors? Okay. Now, I consider that to be an architectural integration challenge. How do we integrate these things into a home such that they are architecturally acceptable? Okay. Now, I have a company that does just that, so you will excuse me if I flip over to another website here. Simplest way to mount a projector, we all know, is we do a ceiling mount. We hang that sucker right on the ceiling, like that. It works, doesn't it? The problem with this is clearly aesthetically, it's not perhaps the optimal approach. That's another view. And there's nothing between the projector and the viewing and listening positions that would stop noise or heat or anything like that. Okay. Still, though, we see 95% of projects, the projector's just hung in the room like that. It is what it is, okay? Now, we always thought that that perhaps wasn't the most optimal way of doing it. How could we do something else to sort of hide that away? So the first thing that we did is the vertical projector mount. So if I click over here, what you'll see is a vertical projector mount allows you to mount the projector vertically. The clue is in the name of the product. Although ironically, you can also do them on the ceiling if you want to project onto the floor, and that has confused people. Instead of that projector being hung up here on the ceiling, you rotate it round, so the depth that you need is dramatically reduced. That allows you to mount the projector on the back wall. Then you can do a very simple screen in front of that helps you to block the noise. So we would consider this to be a micro booth application, okay, micro projector booth. You're not needing to steal too much floor space, but all of a sudden you remove that visual wart on the ceiling. You move it out of the space, and then you can contain the noise and all of that type of stuff. Now, you can typically do a micro booth in about 400 mil, 450 mil. So I'm sure that we're all epic cinema designers as well, who are doing 4 subwoofers at least these days. 4 is like nothing, isn't it? 242 subwoofers in the room. Well, you're usually using that amount of space anyway at the back of the room. Use it for a micro booth and get the projector out of the space. Now, pretty much every serious brand will work on a vertical mirror mount. JVC does, even though they say not. That's just a weird thing in the manual, and it absolutely does. Sony, obviously, all the Arc and all of that type of stuff that are free rotation install can do that. Believe it or not, the Nerthus can even do it. It's a slightly bigger model that we have to use for that projector, but it is possible. Now, what we would also do is we have a porthole. So you see the porthole glass is there, which lets the light beam pass through. I believe that we have a little video here. Oh, it's just all the options. There we go. So you see how the light passes through onto the screen. So it's a super aesthetically pleasing and easy way of doing it. Now, Julian has asked a question about thermal management. Anytime that you enclose a projector, you have to be aware of the amount of heat that's coming off it. Apologies to people who operate in metric. I'm still a BTU guy when it comes to heat output. So if you're talking about a projector that's doing 3,000, 4,000 BTUs, which is pretty common, okay? Something I always like to use to put that in context, a human sitting in the theatre is about 350 to 400 BTUs, okay? You've got to do a thermal system, just an AC system for the cinema, if you put the projector in the cinema, that can handle however many seats you've got, plus 10. That's how much loading minimum you've got to have in the AC system. It's actually for that reason, a lot of the time, it's easier to enclose the projector and just vent that to a space where you're not necessarily so bothered. Maybe the volume of the space that you are venting into is very large, like a hallway or like a utility room or something like that. We don't really care. Maybe you've got a heat recovery system, and actually that's quite a handy thing to have, especially when I came into my 10 degrees Celsius office this morning. I kind of wished I had a projector running in it to heat me up. Um, we're not going to go into thermal management very much in this particular session, but that is one of the key considerations. And obviously, we do have solutions to help you with all of that type of stuff. But when you enclose the projector, you've always got to be aware of it. Now, one of the things with a micro booth like this, the volume of air can be quite large still. And typically that projector is not going to be used for like 10 hours a day if it's a dedicated cinema. It can be that the volume of air is so large that you don't mind if it warms up. You know, if it warms up to 23, 24 degrees, okay, who cares? It'll cool down again once the projector stops being used. I have to say these days that's quite rare though. And almost always we are putting forced ventilation into these types of systems. Now, another way that we could do a hidden projector. Oh wait, look, there's the big guy for the Nerthus and the Freya. That's a big one. Especially when you put it in a hush box, it becomes quite large. So then one of the other solutions that's very popular for us is a mirror drop. So in a mirror drop, what happens is that the projector is above the ceiling. Okay, so that's our containment. It's moved up above the ceiling. The light then bounces off two mirrors and onto the screen. The advantage of this system for us always over a lift was a lift kind of never made sense to me. It makes the room look good when you're not using it. Now, that makes sense if it's a living room, but it makes absolutely no sense when it's a home theatre. In a home theatre, it matters what happens when you're using the projector. So in this case, we always keep the projector away from the room, and we only have a very minimal visual impact of the mirror flap dropping down. So that was why we developed the MMD the way that we did, is to again enable the projector to be hidden and all the noise and all of that type of stuff kept away, with a minimal visual impact. Now, the other one, of course, that we get asked all the time for, and we do a lot of, is hush boxes. Okay. If Sir wants a hush box, yes, we do them. All the way up to these big guys here, large plus. Born Earthus. Oh, we'll have to change that. Now, the benefit of using a hush box, of course, there's the family of them, is that you contain the noise and the heat and all of that type of stuff in a known system. Okay, you can see that the hush boxes have got ducting interfaces built into them and cable entry interfaces and a double glazed porthole, an access for the projector, and all of that type of stuff is built into them. The only real downside of a hush box is a hush box needs to be an absolute total minimum 200 millimeters bigger on all sides than the projector that is going to go inside it. And ideally, you would get more than that. Now, there's two reasons for that. One is that the projector itself heats up. Okay, when they're operating, it's not just that the heat only comes out of the vents. The whole chassis of the projector gets hot, and you've got to be able to let airflow move around that so that it doesn't cook itself, basically. Doesn't become a big baked potato. It'll be a very expensive meal, I can tell you. The second thing is when you have a fan is designed to operate under a specific pressure. So when you have the fans at the back of the projector, as you move them closer and closer and closer to a surface, they actually encounter more pressure and they have to work harder and harder. And there becomes a point where they simply can't work harder to overcome the pressure that's being placed on them. Same on the input side. Even though it's sucking, it can't suck as efficiently if there's no space behind it. So you've got to give it that room. Now, in a lot of models, of course, you get the problem where if the exhaust is too close, it starts to recycle and all of that type of stuff. So a hush box is always going to be a big thing. There's no way that you can get around a hush box being a big thing, but it will very, very efficiently block the noise of the projector and the heat, and they do remain a very, very popular option because of that. Okay. What time are we up to? Oh, we're almost through our whole time. I've just blathered on. Right, I want to talk about screens just for a few minutes. Does anyone have any questions about hush boxes or anything like that? Or architectural integration in general, which we literally built a whole company around? Yep, perfect. Okay, so when we were talking about brightness, I mentioned that projection is always a system. Let me hide this down here. Projection is always a system. The image quality and the brightness and all the rest of the stuff will be heavily dictated by the screen that you're using. And I'm going to assume that we're always using the screen. No one's bouncing this off a wall, hopefully. You know, if you're doing a little media room with an ultra short throw, that can be a fun way of doing it. Bit of white paint sprayed, I'm okay with that. But for a serious cinema, of course, we're going to be looking for a screen. Now, I am unlucky/lucky enough to own DT, and we make projector screens. And one of my biggest frustrations in life is image gain numbers published by projector screen manufacturers. Okay. So what is image gain or screen gain? You'll hear it referred to as. So if we refer back to the brightness image, the lumens from the projector projects down onto the screen. It is then reflected back towards the viewer. And what the gain number describes is what's the efficiency, let's call it. How much of that light is getting reflected back towards the viewer. Now, we make acoustically transparent screens in the main. We do ambient light rejecting, and we do non-acoustically transparent white screens for grading suites and all of that type of stuff. But in the main, we make acoustically transparent screens. Now, when we started the company, it's not my first time doing a projection system. I knew very much the image quality that I was looking for. And so we made certain choices about that. Now, I have to tell you, if you want to get a woven or knitted image surface, your minimum run that you can put through the machines is about 2 kilometers of fabric. If the guy stands there and goes 2 kilometers of fabric goes through in the giant halls that they use to make these things, no one is making in their own factory image surfaces. It's nonsensical to say that. Okay, I want to be very clear on that. what you've got to try and do is work with the mills and all of these types of things to kind of get the properties that you are looking for. Now, almost all knitted screens are polyester. They are a form of knitted polyester. You can bleach it, not bleach it, put some additives in or whatever else. But polyester is not a high gain reflective surface. And if you look at all of our image surfaces on the DT website, you'll see it. I will be happy to send a white paper to anybody on how we test our image surfaces. The gain of our acoustically transparent screens falls between 0.65 and 0.72. Okay. That's repeatedly measured by me very accurately with very expensive reflectance standards and spectrophotometers and all of that type of stuff. And yet I still get people phoning up and saying, XY screen, I should say XYZ screen, that wasn't a pick on a competitor, incidentally, says that their screen's 0.9. I'm like, okay, it's defying physics then. 0.9, impressive. I have never tested a polyester screen that was more than 0.75 gain. Doesn't matter what people write. 1.1 gain, there's an American company, starts with S, ends with N, that claims a 1.2 gain polyester. It's utter nonsense. It's a 0.7. It drives me insane that people lie about that. I had an end user contact us because he was looking at one of the screens and he wanted to buy a DT screen and replace that with a competitor fabric that claims to be 0.8. It simply isn't. Now, even if it was, one of the things you've got to understand is how your eyes function. Your eyes are not linear, they are logarithmic. So a 2x change in the peak brightness is actually quite difficult to see in comparison to a 2x level of contrast improvement, Tom, you'll be pleased to know. So our focus was always about how can we make a white screen, yes, with as good a gain as possible, that's actually white. I don't know if you've ever done screens that are yellow. Almost all of them are yellow. We do not do that. We do a white screen. That was a really important choice for us to do a little bit of tweak on the calibration because of that, but they're always a white screen. You get much crisper whites because of that. But we always do a screen, acoustically transparent, which is black behind with white in front. The reason that we do that is this acoustic transparent screen has an open area. When you put a black screen behind that, you effectively create like a grey screen. It's not grey, it's still white, but it operates like a grey screen because that black helps your contrast and it stops reflections and all of those types of things. So whenever you see our numbers, that's always a black and a white together. And that is the brightness that you will achieve in the space. No nonsense. Now, you can get a little bit higher gain if you use fiberglass. Okay, a woven screen, not knitted, but woven, will often be a fiberglass material. Those screens come from water filtration systems. Just a bit of fun fact about where that type of material was developed for water filtration. You can get a little bit higher gain out of those, but our feeling is that they are much more difficult to work with. They're more solid, whereas a polyester screen has a little bit of stretch, and now we have the silicon edge on it, so you just push it into the holes. It becomes much easier to work with. So do not be fooled by nonsensical gain numbers. And do not get hung up on 0.72 versus 0.8 because it's almost imperceptible. And I've done that demo many times. for people. I did it on Tuesday with a 6,000 lumen projector with a 0.8 gain held in front of it, and you just couldn't tell the difference. Much, much more important is the purity of the white, the contrast, the color reproduction, and the surface texture. You want it to be flat, which is why we go for polyester, not fiberglass. So that was just a little bit about screens. It's really, really important to remember projector and screen as a system. You get it all right, that's when you get your best overall result. Okay, we've overrun a little bit, guys. I hope you will excuse me for that. I get passionate about screen gain, you know, we all have our things. Look, thanks so much for giving up your time this morning. Now, does anyone have any questions? We don't need to rush off if people want to have questions and discuss, or we can take it offline if people prefer as well. Nope. Perfect. Be good. So, guys, I have recorded this session. We will have to try and work out how to put it online. I'm sure we'll get there. So, thank you very much for your time this morning. I hope you found it interesting and enjoyable. We do these things every week. Bit of fun, me getting to rant. It's therapeutic for me. And obviously, we hope that you'll join. And if you've got any colleagues who would be interested, then just let them know. Okay, thanks a lot, everyone. Thank you. Cheers.